Can you imagine how different our lives would be without plastics? I found these plastic items here today in the office. Manufacturing companies have been very successful in producing plastic items. A typical manufacturing process includes converting raw material into a functioning part. Examples for plastic items include thermoforming, injection stretch blow molding, injection molding, extrusion, and extrusion blow molding. However, these processes are generally determined via trial and error, thus creating a significant amount of technical debt. How computer simulations can help optimize farming processes. I'm here today with David Mckelvey, a PhD student at the Queen's University of Belfast. So David, could you please introduce yourself? Good afternoon, thanks for the invitation. I'm doing my PhD in the School of Mechanical and Aerospace Engineering at Queen's. The title of my project is the Thermal Mechanical Modelling of Semi-Crystalline Polymers. So the real value in my work is that it will potentially allow design engineers the ability to create innovative plastic parts to solve complex problems. They'll be able to do this by creating computational simulations that can mimic the manufacturing process and hence optimize it. So David, now that we know a bit more about yourself, could you please give us an overview of how you could potentially do this? Simulations typically have three strands: the material response, the processing conditions, and an experimental validation. Semi-crystalline polymers have regions where the molecular chains are ordered, known as crystals, and regions where the chains have no order, known as amorphous regions. This structure is dependent upon the thermal and strain histories applied, because when you heat the sample, you give the chains energy to break free from the crystal structure. Then, when you stretch the sample, you cause the chains to align in the stretching direction. And finally, when you cool the sample, you allow more crystals to form. The amount and the orientation of these crystals plays a key role in predicting the final mechanical properties of the part. By including the simulation in the manufacturing process, we can optimize the processing parameters to give a specific microstructure and hence provide the specific functionality for that particular part. This in turn removes the trial and error approach, saving time, money, and potentially allowing more creative solutions.